So in this video, we'll continue our discussion on the topic of trigonometric substitutions, and we'll look at an example about this. And let's look at the problem again. Whenever the integral contains a term which is the square root of something, and this something is actually something like x squared plus a squared, or maybe a squared minus x squared, or maybe x squared minus a squared where a is constant, we can always try to use the trigonometric substitution given on the right hand side. Depends on the form that you have. And let's look at the problem now. So please look at the current problem. The integral actually contains the square root term, and the square root contains x squared minus 4, and based on my previous note, it looks like we can use the substitution where x is actually 2 times secant theta. And naturally, we have to write the second step down. And the second step is dx equals the derivative of 2 times secant theta, which is 2 times secant theta, tangent theta, d theta, right? And let's look at the left-hand side together. So we have to replace everything from variable x to variable theta, and let's do the top first. The top is dx, which is the second line on the right-hand side. So it becomes 2 times secant theta times tangent theta times d theta at the top. And in the bottom, it is the square root of x squared minus 4, and once again, similar to the last two videos, we have to express it in terms of theta, and that's the key point here. Our substitution x equals 2 times secant theta works out because we can take out the square root successfully if we do the correct simplifications, and after replacing x by 2 times secant theta, we have to do the correct simplification now. Now you see the thing that inside the square root is 4 times secant squared theta minus 4. And of course, 4 as a common factor can be taken out. And now, please recall a well-known identity you have seen. 1 plus tangent squared theta equals secant squared theta, which means that secant squared theta minus 1 here is the same as tangent squared theta, right? You are taking the square root of 4 times tangent squared theta, which means that we can take out the square root. So the answer is just the same as 2 times tangent theta now, which is the expression which is greatly simplified for the purple star. So I put it into the denominator now, which is 2 times tangent theta. And please cancel the terms at top and bottom when they are common, so 2 can be cancelled. And of course, tangent theta can be cancelled. So you're left with the integral of secant theta. Unfortunately, this integral of the secant theta is not very easy, and the expression for that is actually the same as ln of tangent theta plus secant theta plus a constant c. And you may be wondering why the answer is so strange. And actually, we don't have enough time to explain everything in this short video, but just to let you know, if you differentiate the answer that you have ln of tangent theta plus secant theta, if you differentiate that, by the chain rule, surprisingly, you just get back the secant theta. So you have to try it yourself. You have to try it yourself. So to convince yourself that my answer stated here is actually correct. So the last step is to convert the answer back to the variable x. Can you see how you can do that? So now let's look at the purple start box here, and the original substitution we used was x equals 2 times secant theta, right? And we'll use the classical right angle triangle to help us out. Now, let's look at the right angle triangle. Please recall that secant theta is the same as 1 over cosine theta, right? So it means cosine theta is the inversion of x over 2, which is 2 over x, which means that the hypotenuse, which is the longest length in the right angle triangle, is x. And the base length is actually 2. That's the meaning of cosine theta equals 2 over x, right? And the vertical length, we can get it by using the Pythagoras theorem, which is the square root of the longest length, x squared, minus the base length squared, which is 2 squared. So it means it's actually the square root of x squared minus 4. And please go back to what we have in our answer. So it means the tangent theta is actually the same as square root of x squared minus 4 at the top, divided by 2, right? So I put it back into our answer. So ln of square root of x squared minus 4 at the top divided by 2, it is for the tangent theta. And the secant theta is easier because secant theta, we understand that is just the same as x over 2. So I just put the answer here. And essentially, it is our final answer to this problem. That's the end of this video.